Hi everyone, welcome back to our video tutorial series on surfaces and data trees. So what we're going to do today is we're going to start to look at some tools that help us create surface panelizations. So a surface panelization is just a way to discretize a surface into smaller buildable parts. That means parts that you can manipulate and you can build a surface with. And that's a pretty important part of contemporary architecture. So let's look at some examples first, and then let's try to dive into how to do that using Rhino and Grasshopper. Okay, so surface panelization, like we talked about, is a way of breaking down a surface into smaller chunks that can be manipulated and put together in order to create a surface. And that's particularly important with free-form surfaces because as architects, what we normally try to do is to make a design intent, a surface, and we break it down into smaller parts because of several constraints, manufacturing or materials or transportation, etc. So let's look at that. So for example, this is just a drawing from an office that it's a simple surface, just a sweep surface that has, you normally will have a base surface, and the base surface will be just a it will normally be NURBS surface. So here is the first concept. You have a base surface, and this base surface will normally correspond to your design intent. So what you want to accomplish with your design, what you want to do with your design. So after that, what you do, or basically you turn your design intent into a base surface, and you model that either in Rhino or in Grasshopper or with other software tools. And then after that, you will normally create a grid of, so that breaks down the surface into smaller surfaces, smaller chunks that are buildable and usable. And that can turn into a different kind of panelization. So a panelization is the process of creating a set of panels, each one of these discrete elements. This is a discrete element. Discrete means that it has a defined, like it has a beginning and an end. It's just like a chunk. It's a discrete parts that you can build the surface with. And it's a very important and very common problem in contemporary architecture and contemporary design, where you, like for example here, asymptote architecture, they created the Yas Marina in Abu Dhabi. And this is a surface that has diamond panels. This is a type of panelization composed of diamond panels. There are others where you have hexagonal panels, like in the Soumaya Museum in Mexico City, but you have your diamond panels. And you can have, this is Zaha Hadid Architects, the Heydar Aliyev Cultural Center, a very important project in contemporary architecture where the surface panelization, or each panel here, is basically a smaller part that is created in order to build the surface and sort of attach that panel into the to a substructure, right? And this is basically just the normal kind of workflow or construction process of a project like this, where they will create a 3D structure, and then over that they will put some sort of weatherproofing, and then over that they will put some sort of final form work or final panel. And you can see that here, where they're sort of cladding. That'll be your cladding. To clad something is to cover it. So when you talk about facade cladding or surface cladding, it's just about how do you cover a particular piece of architecture with some material, right? So then a very nice example of that in Mexico City is the Museo de Arte Popular courtyard by Teodoro González de León, which some people from UNAM in the lightweight structures lab created. They created basically a translation surface, the ones we've been using, composed of arcs, and each one of these arcs are segmented, and you sort of create these panels from glass in order to just sort of clad and cover the whole thing. So that's another example there. And this is how it looks like from the outside. You can visit that museum here in Mexico City if you're interested. The courtyard is pretty interesting. And I think that's it for now. Those are just some examples of surface panelizations used in architecture. And what we're going to do in the next part of the video, we're going to look at how to break a surface, a base surface, into smaller chunks that we can sort of build the architecture from. And that normally entails the creation of what's called a grid shell, basically just a grid of elements that are arranged in different directions. Much like the surface U and V directions, you create intersecting grids of elements, and you cover that with panels that can be glass, that can be GFRC or glass fiber reinforced concrete, or other types of structural materials or cladding materials that you use to do that. So let's try and look at that in Rhino and Grasshopper. So let's head over to Grasshopper. Okay, so here in Grasshopper I have pretty much the same surface that we've been working on. I have a translation surface created out of two base curves. And yeah, we sort of have that. It's created with the graph mapper here. We have both curves, the directrix and the generatrix, yeah? And we have that in Rhino and Grasshopper. And then here is the extrusion, right? Oh my gosh, something fell. Okay, so we have that over here. So what I'm gonna do now is I'm going to use the surface utilities divide surface, and here, as we saw in the previous video, we're dividing the surface into chunks, into different directions of the surface. Remember that this is the U direction, and the other one will be the V direction. Let me just get my pen. So yeah, so this is the U direction, and then you will have your V direction, right? So you have your both directions of the surface. You're going on one side and on the other, right? And you can change the count over here. You can change the U count and the V count. You can do that with a slider, or you can do that with the set integer tool. So here we have more divisions on one side than the other, etc., etc. And what you get from this component, if you look at it with a panel, you will get a tree, a data tree. And let me just get that a little bit bigger. You will get a data tree. And remember that in the introduction to this topic, we showed how a data tree is a list of lists. So what that means is that we have a series of points, and the points are arranged in lists, and each list is in another list. So you can see the first thing that we want to show is, for example, you can see the dashed line here, the wire in Grasshopper, it's dashed. It's dashed. So that means each one of these graphic elements is called a dash, like just a small line. And that means that the data that wire is transporting is a tree. And that means that it's arranged in such a way that where you have a big list, and inside of that you have other lists like this one. How many lists inside that list, and then inside of each one of those you will have the actual points, which are the ones that you see here. So for example, this 0, 0, 0, that'll be this first point, and then you have 0, 2.4, 1.8, that'll be this point. And then all of these, you can see that all of these, their x coordinate actually has 0, right? So that means that all of these points are arranged in a tree branch. So a tree branch, let me just erase that. So a tree branch it's the name that Grasshopper gives to each one of these lists that are inside of that first list. So you have, for example, you have these 10 points inside of that first list, and then the next list will be these the next list will be these points over here. These are now the points on the next list. And then the points on the next list, these ones will be these ones, like these ones here. Okay? So in order to sort of look at that, let's sort of look at some of the tools that Grasshopper has for analyzing data trees and lists for that matter. So let's just sort of go a little bit further back and explain some concepts regarding lists and lists manipulation, which are very important in Grasshopper. So let's look at those. And in order to look at those, I'm gonna turn these off. And then I'm gonna just, turn these off again. And I'm gonna just stay with this curve right here. So for example, let's just look at that curve and go to division and then go to divide curve. And what you get in here, you get a list of points, right? If you look at this, you get a double wire. It's not dashed, it's continuous wire. So that means that it's just a single list. When the wire in Grasshopper is a single wire, like this one, it means that it's transporting just one element. You can see that here you have one element. And here you have a double wire and you have several items inside of that list. And then here you have a dashed line, and that means that you have several lists inside that wire, or that wire is transporting several lists, right? So for example, with Grasshopper, like we saw in previous videos, you can go to sets and then go to list, and you can get, for example, the list item. You can get the first item on that list, and that'll be this point right here. You can change the index. Remember, we talked about the index, so you can change the index, which is the spot or the position of an item inside a list. So for example, if I go with 1, you get this point, and if I connect this to a panel, you'll see that this is now a singular, just a single one wire. So that means that you have one item inside of this list. There are many other list creation and manipulation tools. You can, for example, ask Grasshopper for the length of this list. Get me the length. So that'll tell you that this list has 11 items. You can get you can get a sub list, which will be just a smaller portion of that list. Let's, for example, say that you want the second to the or the item with index 2 to item with index 3, and that'll give you just, well, for example, let's just go a little bit higher. Let's just go to 2 to 6, and then you'll get item with index 2, 3, 4, 5, and 6. So you'll get a list, so you get an idea of what these are doing. If you have questions, you can look at some of the additional reading for last topics, where you get a bunch of list manipulation and creation tools. For example, you can shift a list. You can do shift list, where you get a list, and let's just say, for example, this. Let's just get the first item, which will be item with index 0. So that's this item. But if you shift the list, that means that you shift the order of the list over one spot, and then item 0 is now this one, etc. So you have a bunch of tools over here to work with lists. You can reverse lists, for example, just reverse it. So for example, if I see the first item in this list, it's this one. But if I get the reversed list here, the first item is this one. So you can do all sorts of crazy things. And those are very important when you're doing what's called data matching. So when you're working with the Grasshopper, when you have a particular objective, you will normally have to understand the order and the structure in which the lists are created, so that you can modify them and sort of work with them. So anyways, that's just with a single list, okay? So, and you can go back to last topic number 5 to learn more about that. But for now, just know that there are also tools for working with trees, which are lists of lists. So for example, let's just get, for example, the analogous one from, for example, you have list item, no? Where you have just the first item on a list, right? So if you have the divide curve, which is this one, and then the first item, it's that one. So that's just a single item. So for example, here in Grasshopper, you will have in sets tree, you have tree branch, right? So tree branch, a tree branch will normally give you a single branch of the list. And again, for example, this is the tree here, and a branch in this tree is actually this one. So you can see that you have index 0, 1, 2, 3, etc., all the way up to 10, and then it goes back to 0. It doesn't like sort of keep going. It just resets. The index is reset, and you have this this sort of grayish looking division, where that means that it's getting a new sort of sort of a new branch for the tree. So if we and this sort of gray area here this thing here, it's called the branch path. And so what an index is to a list, path is to a tree. So that means, so when you have an index in a list, each item has an index. So this is item 0, for example, this individual item. And in a tree, a branch will have a path. And that's this piece of text right here, this part of this sort of text. So for example, if I go set path, I can type this, which is curly bracket, 0, semicolon, 0, semicolon, 0, semicolon, 0, curly bracket. And that'll give me a list. You can see that this is a list with multiple items, and this is a tree with multiple branches. So that's what's going on here. I'm getting a branch of the tree, which is just a subset of the tree, right? So that's what I'm getting here with this sort of thing here. I can also do the list operations on trees. For example, I can get the first item of every branch. All of these guys will operate on every branch. So for example, if I get the first item of each branch, so each branch will have this, will start here, and this will be the first item, the second one, this is the first, this is the second one, this is the first, this is the second one. And that just deals with how Grasshopper is sort of dividing and ordering or arranging these points. It's called a data structure, right? That's the data structure of this. I can also, for example, one way of doing this, so for example, let's just look at this with a panel. I can, like, this has a tree structure where each branch is a list. But I can also go to sets, tree, flatten tree. And what flatten tree does is it will sort of delete or just, take out or delete the tree structure of the tree. So for example, what it's doing is basically turning all of these items which are arranged in multiple lists, and it just basically goes from this one to the next one in the tree without dividing the branch. So if we hover the cursor there, we can see that we have we have the same amount of points, 231, like the ones we have here. For example, 231 points. The only difference here is that you have only one tree branch, and here you have multiple tree branches. Okay, so that's just the explanation for data trees. And you have other sort of tools for working with data trees. You have merge, you have other sort of things that you can do with trees. And so that's some components. For example, I don't know if you remember, but when we did the grid component, this will also give you a tree. And you can also use the param viewer, which is this component right here, just to see the data structure of something. And it'll tell you data with 5 branches. What this means is that you have one list with 5 lists. And then it tells you here n equals 5. And that means that you have basically 5 items in the first branch, 5 items in the second one, 5 items in the third, same for the fourth. There you go. So basically, oh sorry, so I have 5 branches, not 6. So that's what you get with this param viewer, and it's an interesting way of visualizing just the way it also gives you the branch paths, which are these pieces of text, and so you get that, and you can have multiple nested trees inside a tree. So for example, this can get very complex very fast. You can have, for example, let's just do set tree graphed tree, and what that will do is it'll take a tree that has multiple branches inside, in this case 5 branches, and then every item inside of the tree will get its own list. So for example, you have 5 items inside of each branch, so you will get another branch for every one of these points. That's what graphed will do, right? So each one of these lists will now have one single item, and each one of these lists will have also one single branch path. So that's kind of complex, but you can like for example here, let's just say that this is branch 0, and then this is branch 0 of that branch, and then this is branch 1, and then this is branch 2, etc. So let's just look at how that works. So for example, let's go tree, graph tree, and then just sort of connect that, and you can see that you get 25 branches, and you can see that you get 0, 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and then you get 1, 0, 1, 1, 1, 2, etc. And each one of these get one single item. So anyways, that's graphed tree. So that's graphed tree. Okay. Other important things, well anyway, you also have shift paths, etc. You have other tools. You can just go over to the additional readings in last topic. The Raja Isa book will have ample explanations of this. But for now, just know that whenever you see a dashed wire in Grasshopper, that means that you have a tree, and that you need to work with it with these tools here. So this is, for example, this tree statistics. This will give you the list of paths in all of the tree, etc., etc. You can also get the tree branch. If you don't want to type the whole thing, you can get the paths, and then you can get one path, and then that'll give you the branch for that path. And then you can get, so that's the first branch, or branch 0, and then you can get branch 10, which will be this one, and then these are all just the branches there that you're getting from the tree branch component. Okay, so that's kind of the thing that you have there. So now let's look at more like how to break the surface down. So this is just an explanation of trees, and what I'm going to do now is I'm going to get the surface, and I'm going to go over to surface, utilities, ISO trim. So again, like you can see the description for this component: extract an isoparametric subset of a surface. Isoparametric will be just it has the same u parameter or v parameter, etc. Right? So we can just go over to math and get domain, and then get domain, a two-dimensional domain. Or you can get you can just get you can just construct a domain that goes from 0 to 1 on u, and from 0 to v on from 0 to 1 on v. And if you look at this, you'll see that you have a two-dimensional domain that you get from u to v. And as you can see, this one by itself, it goes to from 0 to 1. And that, like, for example, if you just plug this in here, you'll get the whole surface, just basically the whole thing. You get this thing. Anyway, sorry, you get just a chunk that goes from 0 to 1 on one direction, which will be the u. And then from 0 to 1 on the other direction, which will be the v. But as we saw in the previous video, if we right-click and reparameterize the surface, we get the whole thing, because now the surface domain is redefined or remapped from 0, but 1 is no longer here, 1 will be here, and 1 will be here on the v direction, and you get the idea basically. And now what we can do is we can just go to math and divide that domain. So divide the domain, and this will just basically give us a bunch of domains arranged on a tree, which will be just 0 to 0.1, 0, 0, etc., etc. And it's just a bunch of them. It's just a huge bunch of them, which is just basically all the combinations according to these according to these divisions here. And if you plug that into the domain here, you'll see that you get surface patches. And the surface patch in Grasshopper and Rhino is basically just a subset of a surface. This is one patch. This is another patch. And we can look at that using the list manipulation tools, which are here. So this is the first patch. Let me just turn everything off. This is the first patch, and then we can just basically get all of the other paths here. Okay, so this is just sort of the basic kind of idea of creating a surface panelization. These panels are not planar. Not planar. And what that means is that they're not flat. They're not flat. How do you, like, for example, this panel is curved. It's a surface patch, so it's curved. So it works, for example, when you're doing GFRC panels that can be curved, but you have to form them. Each one needs to have its own mold, for example. And it's different, for example, it's different in a surface like this. For example, this surface will have flat panels that are created out of this cardboard, which is just a flat material. And normally glass or metal panels or other types of panels are created using flat materials like this one. You can see that over there. This is just cartón batería or just cardboard. We call it cartón batería in Spanish. So anyways, that's kind of these ones are not flat, but you can actually create flat panels from these sort of trimmed surfaces, these little smaller surfaces. You can go to Surface, deconstruct BREP, and it'll give you the vertices, and then out of those vertices you can create a 4-point surface, which will be created out of the different from here you get a tree. For example, this is a tree, as you can see here, and this tree out of the deconstruct BREP component is it's actually this tree has a bunch of branches, and each one has four points, which actually correspond to the 4 corners of each one of these surfaces, which will have 0, 1, 2, and 3 indices over here. And that means that you can just sort of get item 0, item 1, item 2, and item 3. And you can just plug them into a 4-corner surface by doing so. And you can just get a flat panel surface from that. When you're doing this with a translation surface, like an extrusion surface like this one, you will normally get all flat panels. And that's sort of the start of your surface panelization. Over here, you can just go over there, and you can just sort of work with that, and we're actually discretizing the surface with this definition. Okay? So, as always, thank you for watching. This is it for this video. You are the Grasshopper files will be up on Brightspace as well, and you will be able to just create a surface panelization. And this is the most basic way of creating a surface panelization in Grasshopper. This is a quadrangular surface panelization, meaning that each panel has 4 sides. It doesn't mean that each panel is a square. It normally will be sort of a skewed square. It'll not be perfectly square, but it has 4 sides, and that it's a quadrilateral panelization. There are other types of panelizations, and we'll look at those further along this video. And we can also create other types of panelizations with our Grasshopper's definition in this topic. So anyways, again, thanks for watching, and I'll see you all on the next video. Goodbye.